Hey kids, Smath here. So here's your answer key walkthrough for Unit 1 progress check. Now, Unit 1 does a whole lot about atomic structure traditionally. This has been a large part of the exam. I would expect us to see it again this year. So this is going to tie together isotopes, mass spectroscopy, as well as electron configurations and ionization energy and periodic trends. So should be a pretty good unit for us. So let's look at our first question here. For the free response questions, we're just going to write these down and answer the following related to potassium. Okay, now let's make sure we read the questions very carefully because some of these are worded very well from the College Board. In terms of atomic structure, explain why the atomic radius. And so we got a couple of things going on here. First off, we have atomic structure, and they want to know why is the atomic radius of K larger than that of potassium? So I've got all these down here, written a little further. Why is the K radius larger than that of potassium? And here are their responses. They give you a couple of shots at this. They say that the valence electrons of K are in a higher energy shell than those of sodium. That's not bad, okay? The outer orbitals have a higher principal quantum number in potassium than sodium. That's another way of saying it just has another shell, okay? And the valence electrons of potassium are less attracted to the nucleus than those of sodium. How come? Because they're further away from the nucleus, all right? We really haven't gone too far into shielding effect at this point, but we probably could play that card that potassium has more of a shielding effect. Therefore, it's not held as tightly to the nucleus and the radius is going to get to be a little bit larger. That would be a perfectly acceptable answer. Now, the second question asks us, I'm going to pull back and say, in terms of atomic structure, explain why the first ionization energy, i.e. 1, of potassium is less than that of calcium. Now we're no longer dealing with a group, but now we're dealing with a period. So why is IE1 of K less than IE1 of Ca? And the response indicates the first ionization energy of potassium is less than that because the electron removed from K is less strongly attracted. We can't say shielding effect in this case. We can just say it's more easily removed. Notice they didn't just say K has a lower ionization energy, therefore it does have, that way it's easier to remove. They've already told you that it's a lower ionization. They're asking why. You also could bring up the fact that they brought up here at the end that the K nucleus has fewer protons. You only have 19 protons in K compared to 20 protons in Ca. So the Ca would have a stronger nuclear charge that would pull their electrons in a little bit more tightly. Okay, so there's part B. What about part C? Part C says K forms ionic compound K2O, which is an ionic compound, there we go, K2O, which is an ionic compound that is brittle. Identify another, sorry, I've got covered up, there we go, that is brittle. Identify another element M that is likely to be brittle and form an ionic compound. So basically they're saying, pick something that's going to bond the same way as the potassium is. And this would be very easy. We're just going to go, scroll back down to the answer here and see what they say. What could M be? M could be anything else in group 1. You guys already know this, all right? Lithium, sodium, rubidium, cesium, even francium. I'll let you have it this time. Not a big fan, but go ahead. The element is chosen because, and we always want to try to give it a why. Why? Because it's in the same group or family, same column of the periodic table. Therefore, it has the same chemical behavior because it has the same valence configuration. All right? And D says that K2O2 also exists, that we could make a potassium peroxide. If we know the mass of the potassium, could we identify the compound as being either? Would we know that it'd be potassium oxide or potassium peroxide? Sure we could. Remember, this unit is atomic structure. We learned a couple of rules, a couple of laws. We learned law of definite composition, that for every 2K masses, there's one oxygen mass. So in this case, this would have a mass. Potassium's mass is 39 times 2. So we would have, 78 grams for every 16 grams. Or if we were to have the peroxide, it would be 78 grams for every 32 grams. And we could reduce those down. So yes, by knowing the mass of it and following the law of definite composition or definite proportions, we could determine the mass of this. Okay, so that's the first question. Now, question 2, I think, is much easier. They're giving us a mass spec chart. And they're saying, how many different? This is percent abundance versus atomic mass. This is what would come out of a mass spectrometer. It's a bar graph instead of peaks, but you know, they're keeping it pretty simple. And they're going to ask us 3 questions. How many different isotopes are there? How could you describe how to use the information from mass spectrum to determine the average atomic mass of the element? Did they ask you to determine the atomic mass? No, they asked how would you use this information? This is one of those subtle little College Board things. God bless their pea-picking hearts. Okay, read the question carefully, because if you just answer this question with your calculator and say that the average mass is 24.3, you're not going to get full credit for this. As a matter of fact, you're probably not going to get any credit because you didn't answer the question, how do I use this information? C was identify the element, and D was write the ground state configuration. So I'm not going to go down to my answers too quickly here because we can do it on the graph a whole lot better. Obviously, there are 3 isotopes going on here. How many different isotopes in the element were in the sample? They only asked how many? 3. Good answer. Describe how to use the information. What I would say with B, and what they did with B, is they showed the setup of how. You also could say that the average mass is going to be equal to the sum of the isotope mass times its abundance. I know you know how to do an isotope problem. You know how to do an isotope problem. You need to explain it in writing. Here's how I could find out that average mass. Okay, C was identify what element it is. The element obviously is magnesium. We know it's magnesium. Let me come back up to the graph. We know it's magnesium because we have something that's predominantly a mass of 24. Magnesium's mass is 24.3. And so what we're looking for is 79%, 10%, 11%. And there's even wiggle room that if you said this was 80 and this was 10, that would be all right. And they gave you whole numbers for the AMUs. Then D says, write the ground state electron configuration for the element you identified, and that ground state is simply 1s2, 2s2, 2p6. Ground state, 3s2. This is your Unit 1 project progress check. Went pretty good. First one, talked a little bit about second one talked about isotopes. First question talked a little bit about periodic trends. 2 very good writing questions. That's our first progress check. We've got another 6 more to go. I'm Smath. I hope this video helped you.